Hello and welcome to this repair tutorial, and today we're going to look at a Marantz and the model number is PM44SE. General specifications: power output is 54 watts into 8 ohm speakers. This increases to 80 watts if you connect 4 ohms and even further up to 100 watts if you have 2 ohm speakers. Frequency response is 20 Hz to 20 kHz and total harmonic distortion is 0.15%. And then in terms of inputs, you can connect a phono, so this is a moving magnet type cartridge on an external record player, and that's 2.5 millivolts. And then also connect video, tuner, tape and aux and DDC. Input sensitivity there is 150 millivolts. Dimensions: height 420 by a width of 118 and a depth of 280, and weight is 10 kilograms. What's important to note with this amplifier is that you have a single balance control. What you will not find is controls for bass or treble. Now, what was the issue when this amplifier came into the workshop? Well, it's the most common one which is always experienced by the owner. Intermittent loss of audio, which can affect both the left and the right hand channels. And there are multiple reasons for that. And as we go through the tutorial, I'll explain each one of those. And if you follow along, if you have such an amplifier that you're repairing yourself, or indeed you own the amplifier, you should be able to restore it back to perfect operation. The first thing that I want to highlight, and I've mentioned this in many tutorials associated with the Marantz amplifiers, is this common ground connection. So you can see that when we need to dismantle it, we're going to need to remove the back panel. And then there's an arrow there which just points to a screw hole, which is for the speaker terminals. Now, there are 4 of them, but you'll also see that on all the other screws there's also a lack of paint, and this is on purpose. So if you're repairing the amplifier, please note that you must insert those ground screws. And what's also important as well, which I'm showing you now, is I've put a circle around what you can see are copper screws, and these are on the heatsink of the main audio output amplifier circuit board. These also are common ground points, and you can see that there are lugs which are screwed directly into the heat sinks, and those make contact again with this common ground connection. Sometimes when you're repairing electronic equipment, you may not reassemble the amplifier completely because you're still fault finding. It's really critical that you have these ground connections fitted. If you don't and you power up, then unfortunately it will result in catastrophic damage to the output stages of the amplifier. Now, like many Marantz, and what we're showing here is the service plate. Now, I always sort of scratch my head when it comes to this, because most service plates on amplifiers means that you would have full access to all of the solder connections and you don't have to fully strip it down. Here with these Marantz amplifiers, you get some access, but not all the access that's required. Now, once you've removed the rear access plate, you can see that on the left hand side, this is the input stage of the amplifier. So you have the horizontal board. This is your phono preamplifier stroke equalizer board. You then have your first lot of line inputs, and then the other board is then for your additional like tape and DDC and also output. The phono preamplifier board just plugs in, and then you have the multi-core cable which then goes over to the circuit board, which is located towards the front of the amplifier. Now, what's really important and what I'm highlighting here is that when this amplifier came into the workshop, it was extremely dusty. Now, this is very common, so you may not be able to see in full detail, but literally all the circuit boards had a heavy layer of dust. So the first thing that you need to do is to remove all of that dust. So I would say here it's quite a lengthy task because you have to get access to all of the different circuit boards and then also the front boards as well. Now, the most common issue with these amplifiers, and this is commonly with a lot of the Marantz amplifiers, is that you have this issue with dry solder joints, and I've mentioned it on many tutorials. Often in the service and repair industry, you may focus specifically at a particular fault that you are hearing or seeing, and then you work to resolve that. That is true here, but you have to do a lot of other work as well, just to ensure that you have this reliability back in the amplifier. So what I've done is I've just drawn a series of circles. The red ones are highlighting particular areas of interest where the flex connectors are connecting from the different boards, and then also where the phono board plugs in. And then on the right hand side, I've circled all of the connections for the RCA input sockets. You need to resolder all of those and also scan just to make sure that there's none of the solder joints which look brittle or are starting to deteriorate. Where I've drawn the yellow box, what that is the input selection switch. And again, you will need to desolder that because we need to remove it. But we'll come to that later. And then here on the additional RCA input sockets, again, we're highlighting that there are always droid joints because there's mechanical stress and also a lack of solder during manufacture. and then also on the multi-ribbon cable as well. And then here what we're focusing on is the input selection switch. Now this is a ribbon type switch, so you have the mechanics of the rotary switch, of course, located on the front fascia, and then as you operate it, it slides a ribbon which then actuates the switch. Now you need to desolder it, as I said, but you will also need to disassemble it. So what we see now is the input selection switch which has been taken apart. And the point to emphasize is you can see the level of oxidization. There's a heavy layer of oxidization, particularly on the ends of the switches. And remember that the ends of the switches is going to be the extreme selection. So for example, the phono input. And that phono input stage is dealing with very, very low levels of millivolts. And you can imagine that it has to overcome this oxidization to try and get any form of contact. So that in itself will lose connection, but also as well, it'll act to some degree like attenuation. So you need to clean it. Now, I've received questions more recently where people have undertook this work and asked the question, well, how do you actually get inside of the switch? Because they've tried to use some pliers just to bend away the lugs. Well, what I show here is just a set of side cutters, and they're just an old pair that I have. And what I'm able to do is just to hook around the lugs and just bend them, not fully back, just vertically, and then that is enough then just to disassemble the switch. And it doesn't cause any damage to the switch mechanism at all, and it's a very, very safe way of doing that. So all that we do is we use a fiberglass pencil, and just make sure you wear hand protection and eye protection, and then it's just a case of just rubbing the fiberglass pencil backwards and forwards, and what you'll find is that the oxidization clears off quite quickly, and then you're left with these bright contacts. And then what I also do is just apply a little bit of De-Oxit grease onto there, and then once you reassemble it, you can then solder it back into the board. In terms of location, you can't really get it wrong, but if maybe this is the first time that you've done the work, as always, just take a series of photographs, and then you can always refer back to them if you wish. What I always do is I will just set the switch from the front just to the end travel, and then I know when I disconnect it and then disassemble the switch, it's very easy then to reassemble and to align it. But you can always test it. And then here on the main board, once you've removed the 4 fixing screws, what you'll find is that there's a couple of PCB pillars that you just need to squeeze in, and then you can lift the board up. Now what I've shown you are specific areas of interest. There will always be dry joints, as I said, but sometimes you may get an amplifier come into the workshop and it's a Marantz and the output transistors may have failed. Now if they have failed, it's because you have these dry joints that have resulted in that. In some cases you may find that only the input power fuse has failed, and then you can replace it, but you must take on this work first of all. So you can see with the red arrows we've circled around the common ground connections on the circuit board. What we've also done as well is we've circled around the audio output transistors which are mounted on the heatsink, the input IC and also the interconnecting cables, and then towards the rear the speaker terminals, and then also the protection IC often is found with dry joints. The yellow circle are the solder connections for the speaker protection relay. You will need to replace it, and again it's all factored in with this intermittent loss of sound. And then as we focus in, just to highlight this point, these are the voltage driver transistors, and you can see that there are cracks around the pins. So you need to re-solder all of these connections and just scan the board, be quite meticulous, make sure that you've not missed any, and then at the same time make sure that you haven't accidentally connected together 2 component leads, and that's what we call a solder bridge. So always verify and then check your work. What I also do as well is I focus on the input power board as well. You can see the switch which then goes to the mechanism to the front fascia, and commonly you will also find dry solder joints on the board. Also as well, verify the fuse holder and make sure that you have integrity on the ends of the fuse holder. With these 20mm type fuse holders, what you can find is that the tension gives up over a period of time, and then sometimes you can get an intermittent contact with the end of the fuse. So just remove it, obviously with no power applied, just squeeze the end of the fuse and then you can then snap it back into position. And then here what you can see is the main power transformer, and I haven't had any incidents where, for example, the transformer has an open circuit winding. You can see that it's a good build quality. You can also see the copper shield here for radio frequency interference. And then here from a top view, what you can see towards the front is the additional control board. Now I always look for dry joints on that board, and you will find that often there are multiple dry joints. There's a particular drop-in resistor, and you'll find that the solder connections around the resistor tended to darken. You can just about make out the resistor in this photograph. It's just after the input selection switch, and you can see where the flex cable arcs over. That's the resistor. Now, to get access to the balance control and also the volume control potentiometers, you need to pull off the control knobs, and then what you'll find is that there are locking nuts. But don't be tempted to use a pair of pliers because you may slip. Just use maybe an adjustable spanner or a socket of the appropriate size. And then you're able to remove the fixing screws which hold in the switch mechanism. And then here what I'm showing you is a close-up view of the volume control potentiometer. So remember that you have to spray into there De-Oxit and then rotate back that potentiometer multiple times just to clean up all of the carbon tracks so there'll be no noise. And then here you have the solder connections. Always a lack of solder, so just re-solder all of those both on the potentiometer and the interconnecting cables. And then here on the bottom board, this is where you have the balance control and also the headphone socket. What I'm showing here is the headphone socket, and it is not uncommon again to find dry solder joints on this. So re-solder all of them. The other most common area, and again this tends to be a lack of solder, is the balance control potentiometer. So this one here has been re-soldered, and you can see now that there is a substantial amount of solder. If you get maybe intermittent loss of sound and all of the other work you've done, but it appears that if you just maybe move the balance control, it restores it, it will tend to tell you that you've got a broken solder track on there and then you need to re-solder. So once we've done all of that remedial work and we've taken care of all of the issues, once we reassemble, then we're into the point where we need to do the output channel adjustment. So this is for the bias adjustment for the left and also for the right channel. So again, you will leave the amplifier running normally for 20 minutes. So you're not going to connect any speakers or headphones. Volume control will be at minimum and your balance control will then be at midpoint. And the area that we're interested in is two areas. The first one is to focus on the bias preset potentiometers, because this is what we're going to be adjusting. And I often say this in many of the tutorials. If the amplifier has never been serviced, then they'll be at the same point when they were factory set. So you may wish to spray them with the power off onto the carbon track with the De-Oxit D5 and just rotate them backwards and forwards multiple times just to clean the carbon track and then restore them roughly to the original position. And then you're going to connect your multimeter on DC millivolts across the emitter resistors, and what you're looking to do is to measure 14 millivolts and make the adjustment with the presets. So here this is before the adjustment, and you can just see just behind the amplifier the multimeter is reading 17.94 millivolts. So it's not drastically high, but it is out. And then after adjustment you can see that we brought it back down now to 14 millivolts. Now what you tend to find with these amplifiers is that if you make a slight adjustment, it normally takes about 30 to 40 seconds just for the adjustment to take into effect while the amplifier restabilizes. So some amplifiers you make the adjustment and it's quite instant. Here with this Marantz amplifier, not so. So just take your time and just make sure that you're not in a drafty environment. And then of course once you've done that, you will do that then for the other channel as well. And then here when we look from the top, this is the amplifier now fully serviced and also repaired. So towards the rear we have the brand new relays installed. All solder joints have been reflowed, which were an issue. The input selection switch, as you saw, was taken apart and thoroughly cleaned. And then also we checked for dry joints on the power input board, and then also on the balance controls and headphone socket. And then the final phase is just to put the amplifier on test. And normally we run the amplifiers in the workshop normally for about 4 hours. And we just make sure that there's no underlying issue or nothing that has been missed. And there was no issue identified here, and the amplifier ran perfectly. So that sort of brings us to the end of this repair tutorial. So again, if you have any questions or you need any help or assistance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any guidance or support that you may require. So until the next time, all the very best. Cheers and bye-bye.